Yesterday we dealt with the surface area of prisms and cylinders, and now we're going into our pyramids and cones. So basically, it's kind of like a prism and a cylinder, except it comes to a point now. So let's just look back quickly. For our prisms and cylinders, I'll just write prisms. To find the surface area, all we did was take the lateral area plus the area of the two bases. So you found the area of one base and multiplied by 2 because they're the same base, right? The top and the bottom, or depending if it's laying outside. And for the lateral area, you took the perimeter times the height, because that basically painted the outside, right? I found the area, the outer part of it besides the bases. Well, it's pretty similar with our pyramids and cones, except now it's coming to the point and we only have one base. So that's going to alter our lateral area a little bit and our surface area overall. Well, before we go any further in talking about the formula for this, we got a couple new things here. Now there's not just one height, there's two different heights here. We have that vertical height in the middle right here, which we call the altitude. And we don't even use that for the surface area. We're going to use that for the volume in a couple sections here. What we're going to use is this piece out here, because it's on the surface. That height is on the surface, and we call that the slant height. The slant height. And we use the letter L for slant height. And the altitude, we still use H, because H is like our vertical height. So we're going to use the slant height now for the surface area. And before, what you would have done is you would have found the area of the four triangles separately, and then the area of the base, and added them all together. But we're going to go and use our lateral area and the area of the base. So let's talk about how this would work. So if I'm going to find the surface area of a pyramid or a cone now, I'm just going to write pyramid down. Well, it's the same process. We take the lateral area, which would basically be the area of the four triangles, right? The area around the outside, plus the bases. But in this case, there's only one base, so I don't need to take it times 2. I'm just finding the area of one base. If you look, right, I only have one base shape. And depending on what shape it is, you could use, it could be a rectangle, it could be a triangle, it could be a polygon, right? So you could use in any one of those formulas. And our lateral areas are just a little bit different how to find. It's not just perimeter times height now. What it is, you got to think, our faces are triangles here, right? So it's coming to a point. So I'm still going to take the perimeter. We'll still take the perimeter. Except now it's not times the height, it's times the slant height, right? Because it's going up at a slant. Plus it's going to a point, so I got to think about a triangle, right? It's not going up from vertice and vertice, it's going up to a point. So that's a little bit different. So we take the perimeter times the slant height and 1/2 of it, because they're basically triangles, it's going to a point. So that's where it's just a little bit different. So use the slant height instead, and we also got to go 1/2 of the perimeter times the slant height. So it's a little bit tricky. And what I like to think of it as, my faces are triangles, and that's where I come up with that 1/2. Right? If I think about the area of a triangle, it's 1/2 base times height. So it's kind of the same thing, except it's 1/2 times the perimeter times the slant height. So that 1/2 comes into play because my faces are triangles for that lateral area. And let's just look closely. So to find the lateral area, just what we talked about. We take 1/2 times the perimeter times the slant height. And just think about where that comes from, right? The perimeter, because we want to paint the outside. But we don't want to use the vertical height. We want the slant height, right? The going up at a slant. So that's why we use L. And we got to take 1/2 because it's going to a point. So it's 1/2 times perimeter times slant height for that lateral area. So if you think about what our shape kind of looks like, it'll make sense on why we use the numbers that we do. So first of all, it says find the lateral area of the square pyramid. So lateral area, it's a pyramid. So I'm taking 1/2 times the perimeter times the slant height. Let's take a look at information we know. Well, it's a square pyramid, so I know that I have a square. So 2.5 times 2.5, well, that would give me the area. I don't need to worry about the area right now. What do I need to know? I need to know the perimeter. Well, all the sides are 2.5 because it's a square, so I can take 2.5 times 4 because there are 4 sides. So that will give me the perimeter of my base. So the perimeter in this case is 10. I'm going to go ahead and plug that in. So 1/2 times 10. And the slant height, do we need to find it or is it given? Well, if I look here, this dashed line is going right to the base of one of the sides. So this would be the slant height right here. So that's good. So L equals 5. And I just plug that in. So 1/2 times the perimeter times the slant height. Well, half of 10 is 5, and 5 times 5 is 25 centimeters squared because it's area, right? Lateral area. So just think, that's the area of the 4 triangles without the base. Okay, so that'd be, I just found the area of like the front triangle, the right triangle, the back triangle, and the left triangle. So the area of the whole pyramid besides the base. So basically, if we want the surface area, all we got to do is add the area of the base. And that's what we got here. So for the surface area, we're taking the lateral area plus, well, there's only one base now. There's no 2 bases in a pyramid or a cone, just one base. So the area of the base. And the lateral area we just talked about for a pyramid is 1/2 times perimeter times the slant height, and then we'll add the area of the base. So just remember, I'm using a lot of variables, a lot of letters, right? That S stands for surface area, right? The capital L is for lateral area. Right, that's the area of basically the side faces. The capital B is the area of the base. Okay, capital P is perimeter, L is the slant height, the small case L. So you just got to know what those mean, otherwise this is going to get confusing. So surface area, just the lateral area plus, well, just one base now. So it says find the surface area of the square pyramid to the nearest 10. So there we go. Surface area, we're taking the lateral area plus the area of the base because it's a pyramid. Well, and since it's a pyramid, it's 1/2 times the perimeter times the slant height for the lateral area. And it's a square pyramid. So how do I find the area of a square? Well, it's either side squared, right? Side times itself, or it's really length times width if you think about a rectangle. I'm just going to use length times width. I don't want to use L. That's better. Let's just keep it as capital B. Otherwise, you're thinking that's slant height. Okay, well, let's do the easy part first. Let's find the area of the base, which I'll use capital B. Well, 8 times 8, or 8 squared, right? Length times width. So we get 64. So I'll just replace that here, 64 for the area of the base. Well, do I know the perimeter? Yeah, 8 times 4. There's 4 sides. So the perimeter is 8 times 4, which gives us 32. So we got 1/2 times 32 times the slant height. Well, let's look carefully now. What are we given on our on our pyramid here? If we take a look, we're given the altitude, this vertical height. Well, that's not the slant height. I want to get this green side right here, this piece right here. Well, how in the world am I going to find that out? I only know that the altitude is 6, that vertical height. Well, if I look closely, what is created right there? I have a right triangle. See how it has that right angle right there? I got a right triangle. Okay, so let's think about what these sides are. So I know that blue, the height is 6. What about that little red piece there? That's 4, right? Because that's half of this side. And it states it right here, 4. So that's 4 meters. So could I find what this green side is, what the slant height is? Sure, that's the hypotenuse. We just have to use our Pythagorean theorem. So we got to take 4 squared plus 6 squared equals, we'll just call this, it should like C, but I'm going to call it L, so L squared. So we're taking 4 squared plus, use red so we can take 4 squared plus 6 squared, the 2 legs, equals L squared, or C squared, whatever variable. I'm using L for slant height. So we got 16 plus 36 equals L squared. So we have 52. So the square root of 52 gives us about, oh, we could just leave it as the square root of 52. That'd be fine. When I type it in my calculator, that'll be more exact. So I'm going to put the square root of 52 for the slant height. And so our surface area, we just take 1/2 of 32, which is 16, times the square root of 52, and we're adding that to 64, which is the area of the base. And we end up with 179.4 because the nearest tenth, and that is meters squared because it is area. So it takes just a little bit of work, How about this guy? Find the surface area of the regular pyramid. Well, let's start with the lateral area plus the area of the base. So 1/2 times the perimeter. Well, do I know the perimeter? Well, 10.4, it's a, what kind of thing I got here? Polygon. 2, 3, 4, 5, 6 sides. So I got a 6-sided, which is a hexagon. So 10.4 times 6, because there's 6 sides, which gives us 62.4. So I'll plug that in for perimeter here. So 1/2 times the perimeter, 62.4, times the slant height, which it's nice. In this case, it's given, right? Here's my slant height. So thankfully, I don't have to figure that out on this guy. So 15. So there's my lateral area. And then we're going to add the area of the base. Well, what's my base shape? It's a hexagon. So this might be a good idea to draw your hexagon separately out on your sheet of paper. There's my base. Here's my base shape. I know that each side is 10.4 centimeters. Okay, now this is going back to our polygon. How do I find the area of a polygon? 1/2 times apothem times the perimeter. Well, we found the perimeter, right? That's 62.4. So how do I get the apothem? Well, we got to draw it in. It's from center to any side perpendicular. And then remember, you got to draw in a little right triangle here. And to figure out what that angle measure is, reimagine breaking up your hexagon into a bunch of triangles. So each central angle is what? 60 degrees, because we got to take 360 divided by 6. So each of those is 60. So for example, like this is 60 degrees, which means half of it would be 30 degrees. So I know right in here is 30 degrees. Well, and I know this whole side is 10.4. Right, this whole side is 10.4, so that means half of that, this piece right here, has to be 5.2. And we have a 30, 60, 90 here. So the 30 side is 5.2. Let's think about our 30, 60, 90. 30 side is 5.2, so that means we're looking at the 60 side now, right? Because we want the apothem here. The 60 side would be x root 3. So 5.2 times the root 3. Or I could use a trig ratio. Okay, I'm going to use my special right triangle. So that means for the area of this base, we got to take this hexagon 1/2 times the apothem, which we just said is 5.2 times the root 3, which we have right here, times the perimeter, which was 62.4. So I'm kind of cramming here. And we type that all into a calculator. And we end up with 281.0, and then we add that to our lateral area, which gives us 749.0 and centimeters squared because it is area. So that takes quite a bit of work because we're dealing with a polygon for our base shape. Okay, we're going to fly through the cone because it's basically the same thing, except the only difference is our base shape is a circle now, right? So for the lateral area, it's still 1/2 times the perimeter. Well, the perimeter is the circumference now of our circle, right? Perimeter is the circumference of the circle times the slant height. So we're still using the slant height. And then for the surface area, it's the same thing. Take the lateral area and just the area of the base, which happens to be a circle. So if I look at it with all my circle stuff, we're going to have to plug in pi r squared for the area of the base. Let's just try one here quickly so we can get a look. A sugar cone has an altitude of 8 inches and a diameter of 2.5 inches. Might be a good idea to draw a picture right off the bat. So that's what I'm going to do. Got a cone, I'm going to put it upside down. Just makes more sense to me. So we had an altitude of 8 inches. That means from the center going straight up, that's 8. And we have a diameter of 2.5. So that means all the way across is 2.5. Well, that means the radius right here would be 1.25, half of that. I'm just going to plug that in as well. It says find the lateral area of the sugar cones in the nearest 10. Okay, so we're not worried about the area of the base shape because we're just doing lateral area. So lateral area is 1/2 times the perimeter times the slant height. Well, if we take a look, 1/2, what is our base shape? It's a circle. So the perimeter is really the circumference. So for the perimeter, we're finding the circumference of the circle. Well, to find the circumference of a circle, you take pi times diameter, or 2 pi r, right? 2 times pi times the radius, either one. I like pi times the diameter, and we're still taking it times the slant height. So now we fill in the information that we know. So 1/2 times pi times the diameter, which it was given, 2.5, times the slant height, which we don't have, but we can find it, because if you notice, we have a right angle here, so here we go. Another right triangle. Boy, we use a lot of right triangles. So I'm taking, L would be our hypotenuse, so we got to take 8 squared plus 1.25 squared equals L squared. So 8 squared, 64, plus 1.25 squared gives us 65.5625, and we're going to take the square root of that, and we end up with 8.1. So L is about 8.1, and we're going to plug that in and finish this off. So 8.1 times 2.5 times pi times 1/2. And our lateral area is 31.8, and it is area, so we got inches squared. And if I wanted to find the surface area, I would just find the area of the circle, pi r squared, and add it to that. And that's all you need to know about your pyramids and